let's get that part started. All right, so here's the basic idea. Was that this is what I said, you all kind of intuitively understand the graphical addition of vectors. Like if you have a tug of war and someone's pulling this way at, with a force of 10 newtons, and someone's pulling back that way with a force of 6 newtons, oh, this person's going to win by a value of 4 newtons, okay? You all intuitively understand it. We just have to make sure that you understand it in terms of physics. So you can do vectors with anything that's a vector quantity. Displacement, velocity, acceleration, forces, momentum, those would be the big 5 that we're going to deal with that are all vector quantities. So here's what I'm looking for example, on number 5. Okay, so this is what number 5 should look like. So, and you're actually going to draw this with a ruler, okay? So you're going to draw vector A, okay? And at least label them so I know what they are, put arrowheads on them so that I know which direction that they're going, okay? If you don't really want to get detailed, you can write, 5 centimeters at 0 degrees. You don't have to, but at least label the vectors. And then you got vector B, all right? And then you've got vector C, which is 4 centimeters at 120, okay? So then what you're searching for, and this is the ultimate thing, is that resultant, which is going to go from the origin out. Okay, so right away, just based upon just a simple sketch, this angle, and this is what your angle always has to be from that positive x-axis. So that angle has to be less than 90 degrees. This is just a very, very crude sketch. Okay, so what we're trying to figure out is that if I walk this way, and then walk this way, and then walk this way, and I've left my calculator, and Alexa says, hey, I got to get Mr. Burkamp's calculator. What am I going to do? This tells her the path that she has to take to get to where I'm at. Okay? That's the nuts and bolts of what's going to happen. So for example, on number 5, that A plus B plus C, that angle should be around 65 degrees. Okay, and I know there's a little bit of variance because you're drawing, you're measuring things, but that angle should be around like 65 degrees. And what you should see on 7, 8, and 9, if all goes well, on 7, 8, 9, all of those angles should be basically the same. And they should be around 170 degrees. So 7, 8, 9 should all have the same angle around 170 degrees. Okay? Now, let's talk about number 11, because this is going to play out large once we get into forces. So on number 11, you've got, this is Bob. So he's going to go like this, and then like this, and then something like this. Okay? Now, so here's the big difference in terms of where you draw that resultant. So the first question says, how far and what direction would the search party travel to find Bob? So on this first one, what we're saying is that the search party is going to start from here, and they're going to go out to here. Okay? So if you're giving that angle, okay, that angle is going to be measured around from that positive x-axis, okay? And so, again, just on a crude sketch, this angle has to be more than 180 and less than 270, okay? So that first angle, if you're the search party, trying to find Bob, okay, this is the path they're going to take, okay? Because they're starting from here and going out to here. Now, when we start to do forces, okay, which is going to be the next unit after acceleration, if these were a series of forces acting on a system, and you don't end up back at the origin, that means that you're going to accelerate. So, like right now, you all aren't accelerating because all of the forces acting on you add up equal to 0. I won't do this, but if I went up to Ismail, because I like Ismail, but if I went up behind him and I pulled the chair out from underneath him, he would begin to accelerate because then the forces wouldn't be balanced. So if these were a series of forces and you don't end up back in the origin, that means that you're going to accelerate in that direction. So on this first one, if you're going to draw this resultant, you'd be measuring around from this positive x-axis, you're here, and you're going to give that angle, okay? Now, here's the difference. If you're Bob and you want to go back to base camp, here's the difference. So what's going to happen here is that if you're Bob, okay, then you're going to give this angle right here. So if you're Bob and you're headed back to base camp, this is going to be your angle, okay? You're going to go up like this. So if you draw a set of forces and you end up back at the origin, that means you're not accelerating. This is what's happening to all of you right now. If I add together all of the forces acting on all of you right now, you're not accelerating, okay? You end up back at the origin. We're going to spend a lot of more time talking about that. I'm just planting that seed right now. So here's, when you answer a question like that last one, what's the relationship between the direction and magnitude of search parties, Bob? Just don't say like the angle is different, okay? I hate that word, okay? The different is just so nebulous, okay? No, or oh, the angle changes. Okay, this is not a political campaign where, oh, I'm for change, or whatever, okay? No, stop. So you want to specifically say what's happening with those angles. Just don't say they're different, okay? Well, let me give you a hint. If you're here, you're going this way. If you're here, you're going that way, okay? They're 180 degrees opposite, okay? You can say something like that, okay? Or, you know, you can actually give the angle difference. I don't care, okay? Just don't say that it's different, okay? It's way, 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 way too nebulous. So, what you should see, okay, when you take pictures of this, okay, I beg of you, make sure that you have these diagrams completely separated out. Make sure that I know exactly which one is number 5, which one is number 6, which one is number 7, okay? Draw them neatly so that, and don't be afraid to look at these images before you send them to me. And also, well, this one it isn't so much relevant, but if there's like 2 pages to like an assignment, send me both pages, just don't send me the front page. Seriously. Okay, is there anything you all want me to go over? Yes, Riley?
Number 9.
Okay.
It's basically the same as number 8, but I could not get the second angle correct.
Okay, so look at this. Okay, so you got vector E, right?
Mm-hmm.
At 180, and then you got vector D at 250, and then you got C at 120. So there's, hold on. There's vector C, and then you got, this is so just a guess, and then you got vector B, and then you got vector A. This is way out of proportion, but this is roughly what
Okay.
it's going to look like.
Okay.
Okay?
Yep.
Yeah, that was way, way, way out of proportion, but that's roughly what it should look like.
I got you.
Okay? Anything else? We're good? Yes?
I had a question about the labeling on number 6.
Yeah, there just isn't one.
Okay, so there's just no angle.
There is no result. On number 6, there's nothing to label. Because, like, if you took 5 steps out this way and then you came back 5 steps, you didn't go anywhere. Yeah, so there's nothing to draw. There is just no resultant. And that would be like right now, you have gravity pulling you down, but you have the chair providing an equal and opposite force to that. That's why you're not accelerating. So your forces right now, there's two of them, and you end up back at the origin and you don't accelerate. Now, I pull the chair out from underneath you, then you're going to begin to accelerate. Okay? Yeah, there's just nothing to put there. Okay. Anything else? Going once, going twice. So at some point, get me those scanned images. Okay, so here's what's going to happen for the rest of the week. So I'll dump out the video after school today on using trig functions to do vectors, okay? That's the last big thing. Then on Thursday, and I'm going to give you guys the review as well, which I'll explain in just a second. Then on Thursday, I'm going to do like an in-class review, and then the test is going to be on Friday. So this won't impact you because you guys are already going to be here on Friday. But I'm also then on Friday going to have the other group come in, so that way we can all test at once, okay? So the next time I see you, and you guys get first dibs to your tables, okay? I've already told them, like, don't come in here and say, oh, that's my table. No, you guys get first dibs because it's your tables, okay? I'll make them sit somewhere else, back the room, other room, whatever. So don't let them bully you, okay? Just say, stand your ground. Now, if you want to be nice and go, hey, if you want to sit there, it doesn't make any difference to me. But I'm just telling you, you all get first dibs. Okay, so anyway, if you're watching this, the explanation of this lab is on the other videos, so I'm going to shut this down.